Hello everyone, you are welcome back again. In today's tutorial, we're going to learn how to solve for the value of x from this unequal base exponential equation. We call this exponential equation unequal base because there is no way we can make these two bases to be the same. This is 7 and this is 5. So in that case, we're going to apply logarithmic to this equation. And to apply log, what we are going to consider, if you look at the left hand side of this equation, we have x here as a power, 2x minus 1. Then the power also here have x, 2x plus 1. So in that case, we are going to take the log of both sides to base 10 in order to be fair. But in the situation whereby the x we are looking for is in one side, then we can take the logarithmic to the base of that number. But in this case that we have x both the left and the right hand side, so we take the log to base 10 of both sides. And remember, when you see a log without base, it means it's to base 10. So we take the log of both sides to base 10. Log 7 raised to the power of 2x minus 1. There's no need to write base 10 because log is the same as log to base 10, which is equal to log of 5 to the power of 2x plus 1. Then recall that when you have a logarithmic of a 10 raised to the power of another 10, then the power is going to come back to multiply the log. So this is going to come back. We are going to have 2x minus 1 multiplied by log 7, which is equal to, then we do the same thing. We have 2x plus 1, then into the bracket of what? Log of 5. Now the next thing we're going to do is to open this bracket. Now we're going to distribute 2x minus 1 into the bracket. Also, we distribute 2x plus 1 into the bracket. 2x multiplied by log 7 is going to give us 2x log 7. Then minus 1 multiplied by log 7 is going to give us minus log 7, which is equal to 2x multiplied by log 5. We have 2x log 5. Then plus 1 multiplied by log 5 is going to give us log 5. Now the next thing we're going to do is to combine the like term. All the 10 with x, we bring them together, then we take the constant together. So we are going to have what? 2x log 7. And when these 2x log 5 cross to the other side, become negative 2x log 5, which is equal to log 5 rather, which is going to be equal to, here we have log 5. And when we take this negative log 7 to the other side, become positive log 7. Positive log 7. Now the next thing we're going to do, if you look at the left hand side of this equation, 2x is common. So we are going to factor out 2x, then we open bracket. 2x log 7 divided by 2x. So 2x will cancel 2x. It will remain log of 7 minus 2x will cancel this 2x. So it will remain log 5, which is equal to log of 5 plus log of 7. So to solve further from here, we are going to recall two properties of logarithm, which is what? Division property of logarithm and multiplication property of logarithm. Recall that when we have log to base a of x over y, this is the same as what? Log to base a of x minus log to base a, log to base a of y. So this is division property of logarithm. As you can see, this bracket is in this form, so we want to convert it to this form. And equally, we are going to recall multiplication property of logarithm. When we have log to base a of x multiplied by y, this is the same as what? As log to base a of x, then plus log to base a of y. So this multiplication property of logarithm. And if you look at this equation, this right hand side is in form of this, so we are going to convert it to this form. So let's quickly do the conversion, then we know the value of x. So this is going to be what? 2x into the bracket of, this is in this form. To convert it to this form, remember this is log to base 10, log to base 10. So we will write one of the log to base 10, then x divided by y. X represents 7, y represents 5. So this is going to be what? 7 over 5 to the base of 10. So the whole of this is equivalent to this, applying this property. So this is now equal to, here we have log 5 to base 10 plus log 7 to base 10. It's in this form. Now to convert to this form, we write one of the log to base 10, then x multiplied by y, then 5 multiplied by 7, which is going to give us 35 to base 10. Now to continue, remember we are looking for the value of x. So what do? We have 2 and this bracket attached to x. So we divide both sides by 2 and this bracket. So we divide the left hand side by 2, then log of 7 over 5 to base 10, which is also we divide both sides by what? 2, then log of 7 over 5 to the base of 10. So the next thing we're going to do, this is going to cancel this, and this 2 is going to cancel this 2. So we're going to have, in the left hand side, we are left with only x, which is going to be what? X is equal to, and the right hand side, we have 2 here. So we're going to factor these 2 out. 1 over 2 into the bracket of log 30, log of 35 all over log of 7 over 5 and all to the base of 10. So we just factor these 2 out, 1 over 2. So this is the value of x. Well, we are not going to leave our answer in this form. We are going to simplify the right hand side further. To simplify further, we are still going to recall one of the property of logarithm that say that when we have log to base a of x over log to base a of y, this is the same as, since they have the same basis, logarithm, then we write log. Then to change this, to change the base, we are going to use the term in the denominator as our new base. Then the new term is going to be what? The term in the numerator, which is this x. So this is equivalence of this. So we just change the basis. This is one of the property of logarithm. So we're going to apply this property. As you can see, this is in form of this bracket. So we're going to rewrite it in this form. And remember, from this log x imply log 35 to base 10, and log y is log 7 over 5 to base 10. So we'll do what? We make this to be our new base, then we make 35 to be our new term, like the way we did here. So this is going to be what? X now be equal to 1 over 2 into the bracket. Remember, the property applied to this bracket, only this bracket. So we're going to have log to the new base, which is y, which is the same as what? 7 all over 5. Then our new term now is going to be what? X, which is the same as 35. So we have 35. So we have successfully changed the base. Now this is the value of x, but if you want to get the numerical value of x, if you press calculator, log 35 to the base of 7 over 5, then multiply it by 1 over 2 or 0.5, we're going to have approximately 5.28327. So this is the value of x that will satisfy this exponential equation. When you plug in this value of x, 5.28327, in place of x here, you are going to see that the left hand side will be the same as the right hand side if you plug the same value to this place. So here's the value of x that satisfies this exponential equation. Thank you for watching, and please follow us for more videos like this.